Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we check out ratios and rates. We're in the Math Common Core standard of ratios and proportions, and we're going to be analyzing using proportions to solve real-world problems today. Our guiding question is, how do we use rates to help you describe real-life problems? Well, if you think about it, you use rates every single day. You might not know where, but let's talk about where you can. 2 to 3. This is a ratio. Looks like a fraction turned on its side, doesn't it? 2 to 3. That little colon there means we say the word 2 to 3. And we see rates all the time. In this example here, bet you've never seen one of these before. This is a mile marker. No, seriously, this is a tornado. And if you look at a tornado like this, you can talk about the rate that this tornado is moving through this city here. My wife and family and I were driving up, and we came upon this tornado, and it was pretty crazy. And the first thing we did, was start talking about math and how tornadoes are math. No, not at all. We jumped out of the car, took a picture, and got back in the car, and were freaking out because we had no clue where we were going. But you know what? Math isn't everything, and we're going to be talking about that today, looking at specific rates and ratios, huh? All right, well, looking at ratios, it's comparison of numbers. Remember, it's just a comparison between two different numbers. Simply put the fractions on their side. So if we look at this, 2 to 3, 2 colon 3, is a 2, the numerator's on the left side, denominator's on the right, and it's a comparison of two different numbers, okay? So if you ever want to turn a fraction into a ratio, that's how you do it. All right, and so let's talk about rates now. Rates are a little different. They are a comparison of two different numbers, but those two different numbers have two units of measure. They have two different units of measure, so feet and seconds. Okay, something like that. And let's talk about some everyday rates that you might see in the world. M/S. This is MS. Any idea what this is? This is meters per second. All right, meters per second. How fast are you traveling? What about this one? MPG. Probably recognize this one. Miles per gallon. That's right, miles per gallon. How many miles are you getting in your car per gallon of gas? Dollars per hour. That one's pretty easy. MPH, another pretty simple one. Or KMPH, miles per hour. And the most tricky of them all, GPF. Any idea? And this one is super frustrating to think about. But you see it every day. Gallons per flush. Never thought about that one, have you? Every time you flush that toilet, how many gallons are you using? I bet if you check out your toilet pretty detailed, and there it is, it'll tell you how many gallons you use per flush. These are rates that you see every day, huh? Pretty weird, but pretty funny that you got math and everything. All right, so let's talk about some everyday real examples that we might use. Whether it's the lunch money you're using per month, you're using rates. All right, describe these rates. 6 hours at $12 per hour. How much money would you be making total? 6 hours at $12 per hour. Well, we just take that 6, multiply it by the 12, because the h is canceled. Remember, if you've got like a 1 on top and a 1 on bottom, those cancel. Or if you have a 6 on top and a 6 on bottom, those cancel. Same as if you have an h in the numerator and an h in the denominator, they cancel. Now this is in the numerator because, let me show you here, we'll put it over 1. And if we multiply across 6h times $12, 1 times h, the h's will end up being on top and on bottom, so they cancel, okay? So that's what you got to do there. This becomes 72 if you didn't figure that one out. What about this one? 6 mows times $700 per mow. Well, mow is month. 6 months and $700 per month. What might be that? What scenario might you use that one with? Well, if you're renting an apartment or something like that, and 6 months and $700 per month to rent it. Well, how much would that be total? Remember, the months cancel because you got a month on top and a month on bottom, and then it's just 6 times $700, and that gives you $4,200. Here they are. All right, you've seen those in the past, I bet. And we're going to deal with them a little bit more today. We're going to talk about a unit rate. A unit rate is a little different than a rate. Unit rate, if you think about what the word unit means, it has 1 in the denominator. It's a rate with a denominator of 1. Pretty simple. So if we talk about something like 65 miles per hour, we don't say per 1 hour, but that's a unit rate because it's per 1 hour, right? 5 meters per second. 5 meters per second. It's not 5 meters per 2 seconds or anything like that. 34 miles per gallon per 1 gallon as opposed to 34 miles per 2 gallons. $23 per hour, pretty good wage there. And 75 miles per 1 hour. Again, we don't say 1 hour, we just say per hour. And then, yeah, of course, 0.5 gallons per flush, about a half a gallon per flush. All right, notice all of the denominators are 1, even with the decimals. And we can just turn fractions into decimals and they can become a unit rate really easily. Because I could have written this one as a 1/2 gallon per flush, 1 gallon per 2 flushes, but I want it per 1 flush. All right. Why don't you work on these by yourself, on your own? 10 gallons at 22 miles per 1 gallon, 9 pounds at $3 per pound, and 13 minutes at 60 seconds per minute. All right, remember the G's on top and the G's on bottom cancel, so then it's just 10 times 22 miles. Pounds on top and pounds on bottom, 9 times $3, and same thing there. All right, and you get this. These is your answers. How you doing? You picking it up? All right. Now working with rates, really to turn something into a unit rate, all you got to do is divide the numerator by the denominator. Turn it into a decimal if it's a fraction, or just simplify it out. So something like this, like $200 in 50 hours. Where does that become? Well, if you just divide 200 by 50, it gets $4 per hour. Pretty simple, right? You just take the numerator, this would be the numerator, in 50 hours, $200 over 50 hours becomes $4 per hour. You turn this fraction, 200 over 50, to $4 per 1 hour. Something like this, 60 miles in 2 hours, that unit rate, 60 divided by 2, that's all you got to do, becomes 30 miles per hour. And then this one, 1 liter in 2 hours, well, this one's a little different because the numerator is smaller than the denominator. Well, it becomes 1/2, and you just turn it into a decimal. Divide the numerator by the denominator, and bam, you get 0.5 liters per hour. Okay, not too bad. Well, let's do this one. There are 12 boys and 15 girls in the classroom. They complete 105 math problems in 35 minutes. Find the ratio of boys to girls. Now, I'll give you a hint there. Don't forget when you're doing the ratio, boys, that's going to be on the left side, girls will be on the right side. And you are going to simplify it like you would simplify a fraction, okay? And find the unit rate of how many problems were solved per minute. All right, those are the 2 problems you're going to be working with. Why don't you try and do it on your own? All right, well, if you do 12 boys to 15 girls, we look at that, we can take out a 3 on each side. Just like if this was a fraction, we'll take out a 3 and it becomes 4 to 5. So that's my answer, 4 boys to 5 girls. Does that make sense? Well, the unit rate, a little different. We have 105 math problems in 35 minutes. Well, how many problems per minute? Well, all you got to do is write 105 problems over 35 minutes. And then from there, you just divide. Simplify it out as a fraction, and you'll get your answer of problems per 1 minute. Because if you have 35 on bottom and you divide by 35, the 35 goes away. All right, here are your answers. All right. Now from this table, I want you to think about how many calories are there per serving of soda. Find the unit rate, really is the idea what you're doing there, is per serving. 0 servings, obviously 0 calories. That's a good soda, isn't it? 1 serving, 90 calories. 2 servings, 180. 3, 270. How many servings per soda? Or calories per serving, rather. All right, notice that you're going up 1 every time there, and you're going up by 90 every time. So really, it's just that rate of 90 per 1, just right here, right? 1 serving, that's your unit rate, 90 calories per serving. And that's it. All right, 90 calories per serving. It goes up by 90 each time, every time you go up a serving. What about this one? How fast does sound travel through water? This one's tricky. Look at it there. Well, you see that let's do a nice even one here. This is 3 and this is 2. Notice it goes right there. So for every 2 seconds, it travels 3 kilometers. So all you would do there is put 3 kilometers per 2 seconds and then divide that out. You'd make the unit rate. So instead of having a 2 on the bottom, you want a 1. So you just take a 3 and divide it by 2. And that gives you the kilometers per second. Make sense? You end up with 1.5 kilometers per second, or 3/2 kilometers per second. All right. Why don't you do this one on your own? How many megabytes do you download per minute? What's the unit right there? Give you a hint, just look at the 1. Okay, looking at the pattern there, just see that it's 30 megabytes per minute. All right, why don't you do these 3 problems on your own? Simplify or solve these problems. You got 20 correct, 16 incorrect. What's the ratio there simplified? 15 hours and 60 minutes per hour, and 180 miles in 3 hours. What are your answers there? All right, having any trouble? Definitely don't forget to simplify this fraction here. You don't need to put the words there of correct and incorrect when you're giving me your final answer. And here, make sure you do label it with minutes. And here they are. All right. Well, that's pretty much it today. Are you able to answer this question of how do you use rates to describe real-life problems? I bet you are. Bet you learned a new one today with GPF, huh? Pretty cool. All right. Well, that's it as we talked about ratios, rates, and mile markers. This was Matt from mathsmath.com. Thanks for joining us. Check us out on Facebook at Solving Maths Problems and on Twitter at MathsMath. And enjoy math and gallons per flush.